All right, well, good afternoon, everyone. Again, thanks for joining us. My name is Alex Laska. I am the Transportation Policy Advisor for Third Way's Climate and Energy Program, where our mission is to put the United States on the fastest and fairest path to net zero emissions. As I'm sure most of you already know by now, transportation is the largest source of emissions, more than any other sector. So we can't get on that path to net zero without taking steps to decarbonize transportation across every mode. Now, we have a lot of work to do in that regard, but the good news is that there's already a lot of work being done. Electric vehicles are on the market and approaching price parity with traditional cars. Hydrogen-powered trucks and trains are being demonstrated at our ports and developed for our railways, and feedstocks are being developed to make sustainable aviation fuels. Importantly, a lot of this work is being done collaboratively, with government and businesses working together to develop new technologies and clean fuels. This year, Congress has an opportunity to supercharge these efforts so we can make sure we meet our climate goals and that the United States leads the clean energy future. And that's exactly what today's briefing is about, how the public and private sectors can continue to work together to innovate so that we can make our transportation network as clean as possible. We're going to hear first from a panel of experts representing industries that are leading the charge on innovation in the transportation sector. Then we're going to have a conversation with Deputy Assistant Secretary Michael Berube, who oversees the US Department of Energy's Sustainable Transportation Programs. So with that, I'm going to turn it over to Ariana Skibble, who is a reporter with E&E News and Politico, and who is going to moderate our panel. During this panel, we will be taking questions from the audience, so please feel free to submit your questions using Zoom's Q&A function. And with that, I'll hand it off to you.
Hi everyone. Thank you all for being here. So today we're going to hear from a panel, as Alex said. So I will introduce everyone we're going to be hearing from. We have Lori Gaytray, Vice President of Business Development at Carbon Engineering. We have Jordan Stone, Assistant Vice President of Government Affairs at the Association of American Railroads. Michael Mayten, Senior Strategist of EVs and Energy Policy at General Motors. And Andrew Lund, Chief Engineer of Zero Emission Vehicles at Toyota Motor North America. Okay, thank you all for being here. Why don't we kick it off with Mike at GM. GM made big news this month as part of the Biden administration's announcement targeting 50% EV sales by 2030. And GM has separately said it also hopes to go all electric by 2035. So talk to us a little bit about why is GM making a big bet on electric vehicles? What has changed in the technological landscape that's made that possible? And what do you need from Congress or the administration or the consumer to make sure you hit those targets? Oh, Mike, you are muted.
Sorry. Thanks, Ariana, and it's a pleasure to be here on this panel. So thank you to Third Way for putting this together. Great question. So, several years ago, our CEO, Mary Barra, put us on this path towards a zero emission future. We know, the zero emission future is an inevitability, and we think with the advancements of the last several years, we can accelerate that transformation. Particularly the advancements we've seen on the battery side in the past 5 years, getting to lower cost, higher energy density, lower cobalt chemistries, like in our Ultium system, that gives us the confidence we can deliver no compromises electric vehicles to customers across the portfolio. Designing EVs really around the battery, kind of from the ground up, really allows us the confidence to know that we can deliver those products. And at the same time, there's this rising customer interest in the electric vehicles. Pair that with the commitments we've made to our board of directors and our investors about achieving science-based targets for CO2 reduction, carbon neutrality by 2040, an aspiration to eliminate tailpipe emissions from our light-duty fleet by 2035. So we really feel we can be a part, we can lead, be part of the leadership of this electric transformation. In terms of what the government can do to really kind of kickstart this, as Alex said, or amplify the efforts, we always talk about 3 I's, incentives, infrastructure, and investment. So consumer incentives, are still needed, giving them the confidence that that they're making the right choice. Obviously, EV infrastructure, and part of that is of course in the infrastructure bill itself, making sure that charging is at least perceived as ubiquitous out there, that people don't feel that they're not going to be able to get a charge when they're on a long road trip. And then finally, investment, and that's really about investment in domestic manufacturing of battery cells and packs, and investment in the EV battery supply chain. This is kind of a new area for the auto industry, really trying to, in a sustainable way, at a competitive cost, bring that raw material and all of that battery manufacturing into the US to bring even more efficiencies, bring those battery costs down further, and ensure the security of the supply chain. So a lot of room for the government to play. We're really excited to be a part of this. And you know, everything we see coming out of Washington is definitely heading in the right direction.
Yeah, so you mentioned bringing the battery costs down on the supply side. Can you speak a little bit about how you're going to do that, and more generally, just how do we make EVs affordable? I mean, that's one of the big barriers right now.
Yeah, I think there's a couple ways. I think one of the ways is by partnering with entities like the Department of Energy to come up with those new chemistries, the next generation of chemistries that are gonna eliminate some of those conflict minerals from the battery chemistry, get to a cobalt-free chemistry, but also move to a lower cost, higher energy density chemistry, whether it's solid state, lithium metal anode, pick your kind of future chemistry state. But we know in order to make this transition, we need to give some customers higher range, we need to give others a lower cost, but we know customers aren't going to compromise on that range to get to that lower cost. So partnerships with the DOE, and frankly in universities to do that research, make sure that innovation occurs in North America, that's a real positive. At the same time, we want to make sure we have the consumer incentives in place, to give them the confidence. And one other thing on the battery side, I'm sorry, I mentioned the supply chain. We think there's efficiencies to be wrung out of the battery supply chain. The auto industry is all about the supply chain. That's come into real focus, of course, this year. We feel that we can bring some of our rigor and some of our efficiencies in the supply chain area to a new area, which is really this battery raw material, the chemical processing, bring some of that closer to where the cells are going to be manufactured, which in GM's case, you see it behind me, that's one of our Ultium cell factories that's going to be operational by mid-decade. So we're really excited about the opportunity to bring those costs down, but it really is still all about that battery, and making sure that we can have domestic production and at the same time improve the chemistries to bring those costs down, and of course manufacture them sustainably.
Yeah. So one more quick question. You mentioned a longer range, or the appearance of longer range. Can you speak a little bit about what needs to happen to extend the range or to have faster charging, and are there trade-offs, and talk a little bit about what you mean the appearance of longer range?
Yeah, no, I think longer range is really important. We know 300 miles of EV range. We've done studies for the last several years. We know 300 miles is where the majority of customers say, okay, that's a vehicle that can fit into my lifestyle. But we know other customers might need 400 miles to make that switch. They live in maybe a colder climate, or have some other factor that requires that longer range. So we know we have to get to those longer ranges, which again brings the energy density and the battery into the equation. And as far as charging, I think the biggest thing is to make sure that we future-proof whatever infrastructure we do put in. to make sure that those chargers we put in, first of all, are accessible to everyone with an EV, but also to make sure that we're not installing something that we're going to have to reinstall or spend a lot of money to upgrade in the next 10 years. We really need to make sure we have those, DCFC chargers in place, and they operate at a high speed and can adapt to the technologies coming down the road.
Okay. Thank you. I feel like we could talk about this all day, but let's keep going. Lori, can you sort of talk to us a little bit, walk us through how this technology works, and what are the opportunities that exist for direct air capture and air to fuels, and what are sort of the biggest hurdles?
Thanks, Ariana, and thanks to Third Way for hosting this panel on this very important topic, and to the audience for your interest. Direct air capture is a kind of a new kid on the block, so I'll explain a little bit. And really, if you take a look at what it is, it's really a big vacuum cleaner. So we're able to suck CO2 molecules out of the air at very large scale and at very low cost. And it sounds like a bit of a magic, but it's not. It's actually something we've been doing for decades, and that's how we put people in spacecraft and submarines, is we know how to scrub CO2 molecules out of the air. They're quite dilute, 0.04% of the atmosphere, the molecules floating around us are CO2, but they're of course already causing climate change, and we need to remove carbon dioxide from the atmosphere. So what we've done is simply, back in 2009 when we were founded, we were kind of a backup plan. The world was working really hard on reducing emissions, which we still need to do first and foremost. But it was a backup plan with some seed funding by Bill Gates to say the world might need to be scrubbing CO2 molecules out of the air. And what we didn't know how to do back then was how to do it at large scale and at low cost. So we set out on an R&D path to figure out how to do that. And what we did was we pulled together some clever chemistry with some off-the-shelf equipment. The air contactors in behind me are our air conditioning towers, calciners, pellet reactors, equipment that was available at full scale in other industries, into some clever chemistry that, and our target has always been a 1 megaton plant, so scrubbing 1 million tons of CO2 per year at $100 per ton. And then in 2018, what we did was we published a paper showing all of the technology and all the techno-economics, and we're now deploying that technology at commercial scale. And the project in behind me is a rendering of the first project we're designing with our developer in the US, 1.5, who's implementing this first megaton scale plant in the Permian, which begins construction next year and starts to capture carbon in 2024. So it's ready, the technology is ready, we're deploying at scale. Scientists say that we might need to actually be scrubbing 10 to 20 gigatons, 10 to 20 billion tons per year by the time we get to 2050, in addition to everything else that we need to do on climate change. And we need an all of the above approach, reduce emissions everywhere we can, and then remove CO2 at very large scale. Once we've captured those CO2 molecules, so input to our process is air, energy, and water. Output from the process is simply a pure stream of carbon dioxide, atmospheric carbon dioxide. The next question is, what do we do with those molecules to make it economic to build the projects and also decarbonize transportation? And the answer is really two things. One is that we can simply put those CO2 molecules back into the geosphere, back into those geologic reservoirs where we found the fossil carbon in the first place. And the other thing we can do is we can take the atmospheric carbon and convert it to a low carbon fuel. So in that case, we put it together with two more off-the-shelf building blocks, clean hydrogen and a fuel synthesis system, and we simply convert it to long-chain hydrocarbons, and we can make drop-in compatible diesel fuel and sustainable aviation fuel, which help to decarbonize. And in that case, we're going to put the CO2 through combustion again, or the fuels through combustion again, and add the CO2 back up into the atmosphere. But now we're recycling the carbon that came from the atmosphere rather than having to pull a ton of fossil carbon out of the geosphere and add it back up. Those two solutions are actually affordable today versus existing solutions that we have to decarbonize transportation, which is how we're able to go forward. And the challenges that we face in deploying, really, we will, the technology is essentially infinitely scalable. So there's no practical limit to the amount of wind and solar energy we can tap into to help drive these plants and the markets for this. We need to be doing a lot of this as quickly as we can. We will continue to innovate on the technology and help bring the costs down over time. But the innovation that we really need today is in policy, really just to make sure that these technologies because they're new on the scene, are included in decarbonization policies that we have in place. As we look at the policies that are out there today, it's actually only the California low carbon fuel standard and the Washington state low carbon fuel standard that currently recognize direct air capture and geologic sequestration as one of the tools to decarbonize. So more coming, but we will go as fast as markets pull us.
Yeah, so that sort of segues nicely into my next question, which is, what do you think the role of the federal government should be in helping continue to develop this and to scale up, especially when it comes to aviation fuels, which is being talked about as a potential for that?
Yeah, absolutely. So we're really excited. There's lots of discussion about direct air capture in the last few years at the federal level. And in fact, the infrastructure bill has quite a number of tools in that toolbox to help to accelerate the build out of direct air capture and air-to-fuels technology. So we're really excited about that. There are also a number of tax-related proposals that have been tabled and are being considered, like a blender's tax credit for sustainable aviation fuel, an enhancement to the 45Q tax credit, which would be, again, help to boost and accelerate the deployment of this clean technology and make this affordable solution available. So those key changes, if passed, would definitely help.
Okay, thank you. Andrew, you are up next. So Toyota has announced a lineup of battery electric vehicles, but is also promoting hybrids and plug-in hybrids and hydrogen fuel cell vehicles. So tell us a little bit about Toyota's approach in promoting a lot of various different technological offerings.
Absolutely, and thank you, Third Way, for having me here, and for all the audience. You're chiming in, you're joining in, and we are the ones that are going to make the change together. So thank you for your attendance. Yeah, Toyota has always taken a portfolio approach, and let me explain why. 30 years ago, Toyota started developing electrified vehicles. And at that time, we focused on Prius hybrid development as well as fuel cell development. And the Prius, as you know, we launched very quickly. And then we also were developing battery electric vehicles, launching a EV vehicle in 2012, as well as the Mirai in 2015, the most recent one in 2019. And the reason why we've taken a portfolio approach is that our strategy, as we have announced in the 2050 challenge, is to really reduce our carbon footprint by 90% by 2050. And that's a big number. And it's good to have aspirational goals, but we need to actually make it happen, because that's what Toyota focuses on, is real results. And so when we consider then the short term, midterm, and long term, we understand that there are technologies like battery electric vehicles and fuel cell electric vehicles that are very ideal for zero emission, and they can get us to a very good goal. But the infrastructure is not ready today to make a big impact on those vehicles. And that is the role that we have with, for example, hybrids. A hybrid still uses gasoline, but it's much more fuel efficient. And for example, Toyota has sold 4.1 million Toyota hybrids in the US. And that equates to 9.3 billion gallons of gas that's been saved as a result of that. And that equates to 38 million tons of CO2 already reduced. So looking back, we've made a footprint reduction. Going forward, we're going to keep looking at all four of those technologies for the most optimized way to make real results. And what that means is the product and the infrastructure need to work together in harmony. And for that to happen, we need collaboration. We need collaboration with infrastructure corporations and suppliers and government. And that's really how we can go forward. If we have a clear target, and if we have incentives, we can get technology launched early, and that provides the ability to get the economies of scale so that it can be a standalone technology on its own in the future. And we saw that happen with hybrids. I remember when hybrids were launched, we would hear comments like, a hybrid will never work, it'll never be profitable, it'll never, well, today we know that that wasn't the case. Hybrids are very good product line. And we see many of them on the road having a real impact. when we look to the future, we have challenges. We have challenges with battery electric vehicle battery pricing, as Mike already talked to, and we have challenges on hydrogen infrastructure, and we need to solve those together.
Thank you. And just want to throw out a reminder for attendees that you can submit questions with the Q&A function. We're going to have a Q&A in a couple of minutes, so want to make sure you get some questions in. Andrew, one last one for you before we move on. Tell us a little bit about the hydrogen-powered trucks that are being used in the Port of Los Angeles, and how you partnered with the California Air Resources Board on that, and what that looked like. You were speaking about partnerships and collaborations.
Thank you. It's really a great example of partnerships, really deep partnerships between industry and government. And let me give you an example. When we announced the Mirai fuel cell vehicle at the Tokyo Motor Show in 2013, we started selling it later in America. But the California Air Resources Board saw that, and they started a discussion with us saying, we see this technology, we see it works on light duty vehicles, obviously, but how about for heavy duty? We have a need. How about for heavy duty trucks? Can we do that? So we started this discussion with them, started to investigate what it really means. We needed to learn a lot about the heavy duty industry. And then we started a very close investigation with the Port of LA in 2015. In 2017, we launched the Alpha concept vehicle, the Beta proof of production concept vehicle. And then, as you know, in 2019, in collaboration with Kenworth, as well as the Port of LA and with Shell, and also truck fleet users, we have been able to produce 10 vehicles and are putting them into use in the Port of LA. And it's really important because, we talk a lot about carbon reduction, it's very important. And we know the impact on global warming, very important. But when you go to LA and you see the neighborhoods around the Port of LA, they're already challenged neighborhoods. And the cancer rate is 1.7 times higher because of the I-710 corridor. And when you see those children playing on the soccer fields, you realize not only can I help the planet, but I can save that child, I can help that child right there. It's a tremendous motivator. And so our team was really motivated that we could make an impact right away, right now in LA. And then this model, once developed, we now know how to do it. We can work with other ports, and we're getting inquiries from other ports around the country. Hey, how'd you do it? What can we do? And we say, well, let's set clear targets. We need the government to help us set clear targets. And then we need incentives to help get the technology going. Once that gets going, you can get to the economies of scale. So we're really excited. We're really ready to move forward on this.
Okay, thank you. So many more questions, but yeah, I want to make sure we get to Jordan. So tell us about some of the zero emission locomotives being demonstrated. What's most promising? What are sort of the remaining hurdles that need to be overcome?
Sure. Well, first, I'd like to thank Third Wave for having me here, and for my other panelists. It's been really interesting learning about your respective companies. I guess I'd like to start off by saying that railroads are currently already the most fuel efficient means of transporting freight over land. We move about 40% of the nation's freight volume for long distance hauling, but only account for about 1.9% of transportation related greenhouse gas emissions. So nearly anything that's moving by freight is already a lower emission movement. But freight railroads aren't resting on those laurels and intend to meet the dual challenge of the increasing freight transportation demand of our country, while also reducing our greenhouse gas emissions associated with our operations. All 7 Class 1 railroads are participating in the Science-Based Targets Initiative, which is focused on limiting global warming to under 2 degrees Celsius. And as part of that, freight railroads are working to develop a broad set of alternatives to traditional diesel fuel and have undertaken demonstration projects to test the viability of primarily two types of alternative fuel locomotives, the first of which is battery. Most notably, BNSF and Union Pacific are both currently working with a prototype long-haul battery electric locomotive as part of a hybrid consist. We've seen success in reducing emissions associated with our operations in an early test that was undertaken with BNSF, which was also done with CARB as well as Wabtec, the locomotive producer. And then the second of which is hydrogen locomotives. And one of our other Class 1s, Canadian Pacific, is working to develop the first ever line haul hydrogen power freight locomotive and plans to conduct trials and qualification testing in the near future. You'd also asked about challenges. And I will say that I think it is very real to say that challenges still exist in the rail industry. You know, these technologies that are currently being researched, such as I previously mentioned, hydrogen and batteries, are still at pre-commercial or initial demonstration stages and will require significant improvement primarily in two areas, cost and performance, in order for those to become commercially viable. I will highlight that to meet these future challenges, the rail industry is committed to continuing to make the $25 billion in annual investments that it already makes into it, building and maintaining its infrastructure, as well as developing innovative technologies. We also, though, support working collaboratively with the Departments of Energy and Transportation to accelerate this ongoing research. And hasten the availability of alternative fuel locomotives for widespread commercial use. I really can't emphasize enough the impact of early proactive federal investment in helping with these efforts in order to be able to meet long-term greenhouse gas goals and our greenhouse gas emissions goals in the future. But also because locomotives are significant capital assets with extended economic lifetimes. So having this availability as early as possible is very important.
Thank you. Yeah, so we just have a minute left before we move to the audience Q&A, but I wanted to ask one last question sort of for all of you, which is, and we'll answer, this is a massive question in a short amount of time, but so do your best. Everything you've laid out is very promising. It will require a lot of investment, a lot of time, and a lot of just shifting the way we've done things for a very long time, which tends to take time. As we know, the climate crisis means that we don't have that time. How do we balance moving quickly as possible with the reality that this is a massive transition? Whoever wants to go first.
It's a great question. Let me try. Yeah, it's all about how quickly can we make an impact today. So, for example, if I were to drive a battery electric vehicle today, and if I were to drive it in Los Angeles, then the grid is about 20% sustainable, and I think the city of LA is planning for it to go to 50% by 2025. So therefore, that's important, but it's still only 20%. So we need to work together, because even if we have a battery electric vehicle, if the grid is not green yet, then we're still not getting to our goal, which is really carbon neutrality or carbon reduction. And that's where other technologies can play. We can be smart in how we drive. We can immediately use the technology that's available, use the gasoline more efficiently with plug-in hybrids and hybrids, and then look at long-term being ready to switch to battery electric when that grid really gets to sustainable where we need it to be. The same thing as Lori was saying about the hydrogen. Getting the carbon captured is very important. Getting to green hydrogen is important. And these are important infrastructure items that need to happen in parallel with the vehicle production for us to really make a combined reduction on that footprint. So we just need to work together quickly.
Yeah, Lori.
I could take this as well. A great question, echoing something that Andrew said, really taking action today. So way to make this big hurdle that we have in front of us, help us all work together to overcome it, is to start to take action. And that's something that we're seeing in the voluntary market, carbon market, is that companies like Microsoft and Shopify and Stripe are saying in advance of being required to remove carbon or decarbonize, they're voluntarily purchasing carbon removal as part of their sustainability plan. So they're saying the climate emergency is here. The world needs to take action. We are going to spend some of our sustainability dollars on permanently removing carbon because the world needs to, not because we're required to do so. And that sends a signal to the world that it's possible to do this, raises awareness about the need to do it, and also signal to lawmakers that that it's urgent and we need to do so. So it's possible for companies and individuals to actually purchase permanent carbon removal today from our projects that are coming online, and from others that are doing permanent carbon removal. So I would say just taking action today, everybody sends that signal and makes it go faster.
Yeah, and I would jump in just very quickly and say, railroads are investing continuously every day in trying to develop these technologies and improve our fuel efficiency in every way that we can. Part of this has allowed for us to increase our fuel efficiency by 17% since 2000. And it's everything. It's more than just the locomotive. It's the cranes and yards that any sort of where that we can trim our fuel usage down is something that the industry has been working heavily on. And we hope and look forward to getting to partner with the federal government on a bunch of the bills that are moving forward in both appropriations and in the Senate's infrastructure bill. We're big fans of both of those efforts, and very much look forward to working with them in the future.
And just to weigh in, we really can't afford to wait to really focus on our all electric future. We believe in an intense focus on electric vehicles and potentially on fuel cells and more energy intensive applications is really the way to get this transformation started. And everyone's right. It really takes the whole of government and the political will to move us towards that future. We can make the vehicles, the infrastructure's got to be there. And for that to be there, that requires a lot of work on the state and local side, and the local utility side, in the grid side for transportation and energy storage. It really has to be a coordinated effort kind of at all levels of government to really make this transformation. But we're up for the challenge. We think, again, what's in, as Jordan said, what's in the package is absolutely heading in the right direction. Although maybe the infrastructure could be a little bit more money. We think that's a nice start on the infrastructure side. But we're excited. We feel we really can't wait to start moving now towards that all electric future. Thanks.
Thank you. Okay, so now we have a couple questions from our attendees. This one is for Lori. Are there any ways to improve the efficiency of direct air capture by having the DAC facilities located in areas with higher CO2 concentration, maybe close to airports or industrial centers, or even CO2 capture at the source?
Yeah, it's a great thought, and there are point source capture technologies. So there are different technologies that are, for instance, scrubbing the greenhouse gases out of feedstocks, point source emissions, which is another key building block or a key tool in the climate change toolbox. Carbon engineering's technology is directly scrubbing CO2 out of the ambient air, and the questioner is correct. Where we happen to be located, adjacent to some emissions, we would actually scrub a little bit more out of the air if it's a higher concentration. But the reality is that the world emits about 4.5 million tons per hour of carbon dioxide, and that CO2 gets redistributed across the planet fairly quickly. The atmosphere is always moving around us and redistributing it. So when we look at how to deploy and where the strongest economics are that let us build out these projects, what you tend to find is that because the CO2 is recirculating, we put the projects where the economics are best, and that means where do we have abundant wind and solar energy that's cheap. And also, if we're going to do a CO2 sequestration project, where are those geologic reservoirs where we're going to put the CO2 underground? We can put a DAC project right on top of those reservoirs, essentially, so we don't have to pipe it. We just put it straight down into those safe reservoirs. If it's an air-to-fuels project where we're going to take that atmospheric CO2 and convert it to a low-carbon fuel, then again, we're driven by the economics to be where we have inexpensive renewable energy, and then fuel markets or a means to take that fuel to market. So if it's sustainable aviation fuel, where do we have those large airports that are going to support decarbonizing aviation, or low carbon diesel? So where are we going to transport those fuels? But we have to sort of look at that whole picture as we look at where the most efficient package is. The DAC plant is already a very nice, tight package that's been designed to be really efficient at scrubbing CO2. So we use about 100 times less land and about 200 times less water to do the work than it would be for a biological alternative like planting crops and then sequestering the CO2 that way. So it's important to also do that in all of the above approach, but we're already designed to be a very, very efficient package to scrub CO2.
Thank you. This question is for Jordan. If railroads are thinking about refueling infrastructure for battery or hydrogen powered locomotives, how do we make sure they can refuel at rail yards, and how quickly does that need to be built out?
Well, definitely. I mean, depending on what technology comes forward and shows significant success, we will need associated infrastructure that will go along with that technology. I would say right now, because we are still at a pre-commercial level, it's a little difficult to map out how and where you're going to put everything in which yard. But I will say what's important right now in terms of getting investments out the door. ARPA-E has come out with $4.5 million recently to go with 4 projects to provide tools to freight railroads in developing and evaluating new propulsion technologies, and as well as their associated charging and refueling infrastructure, in order to make sure that we're getting maximum performance as well as lowering their costs in the future. And I also wanted to point out that the House Flood Appropriations Bill also includes $5 million in research to support freight railroads' efforts with DOE in conducting research and testing for alternative fuels for locomotives. And the key here is that this money is going to accelerate the availability and get these things a little bit further developed down the line before we start putting a ton of infrastructure out and having everything completely throughout the freight rail industry. And this funding and getting that in is key.
Thank you. So this question is both for Michael and Andrew. What are you doing to enable faster charging and build out charging networks? So Mike, why don't we start with you?
Yeah, I think so. We have announced a partnership with EVgo to build out a network of fast chargers, essentially tripling the amount of fast chargers available nationwide. So we're in the middle of that right now. The first several hundred have already been installed. So we know fast charging, especially along interstate corridors, is really, really vital to giving customers the confidence that they can take long road trips. So we're partnering there. The other thing we're doing is really looking at the consumer experience, making sure that those chargers, when you get there, are available, making sure that connection and payment is seamless. Right now, there's a bit of a patchwork, quite frankly, of charging networks. It's a bit like when the cell phone industry first started out. You had roaming charges, and you had a lot of different players in that market. So we have a lot of efforts underway to kind of bring that all together. We know that experience has to be, again, just as simple as kind of filling up your gas tank, and has to be seamless for the customer. So a lot of activity on the infrastructure side from a GM perspective.
Thank you.
Yeah, and from Toyota, we announced our Beyond Zero vehicles, and as part of that, we need to collaborate with basically infrastructure manufacturers. We know that the initial large base of customers that will buy battery electric vehicle will be buying them in and around the towns. So having the ability for people to charge in the towns and in their homes is certainly the first step. But beyond that, then fast chargers does enable customers to be able to use their battery electric vehicles a little bit longer, a little bit farther, and without as much range anxiety. So certainly a very important part of expanding beyond the city centers, but that's where we see the initial growth, and certainly in California, that's where we see the sales now.
Okay. So I think we are quickly running out of time here, but we will take one more about rail. The newly passed infrastructure bill allocates $66 billion for rail modernization. How can rail industry reduce their emissions during this new build out, especially in their scope 2 and 3 emissions? So I guess, Jordan, that is for you.
Sure. I guess starting off, a tremendous amount of the money within the package for the BIF, let's just use an easy reference, is intended for passenger rail. I can tell you that the freight railroads are very supportive of Amtrak having money in order to maintain its critical infrastructure, especially along the NEC. And we are very supportive of a lot of the pots of money throughout the bill. Two that come to mind off the top of my head in the transportation side are both CRISI and the Port Infrastructure Development pots of funding. I know CRISI, which is a rail-specific grant, include funding eligibility for the overhaul and purchase of locomotives that reduce emissions. And the Port Infrastructure Grant does include funding to purchase, I believe it's electric vehicle charge and hydrogen refueling infrastructure for locomotives that specifically service the ports. And on the energy side, there's an industrial emissions demonstration project that includes money to reduce emissions in long distance transportation. All of these can be extremely impactful in how our operations can develop moving forward. But I also want to note that, as I believe Michael did very eloquently, point out that there are a ton of programs in the BIF as well that support the development of underlying technologies for batteries and hydrogen that are extremely important in our view in getting these technologies to a commercial stage that can service locomotives. And that would be my best answer for the BIF.
Great. Well, thank you all so much. I feel like, we could talk for many, many more hours, and we're just skimming the surface, but so much to dig in to here. So Lori, Mike, Andrew, and Jordan, thank you so much. And I'm going to turn it back to Alex.
Great, thanks a lot, Ariana. And again, thank you to all of our panelists for a really interesting discussion. Next, I'm really excited to be joined by Michael Berube, who is the Deputy Assistant Secretary for Sustainable Transportation in the Office of Energy Efficiency and Renewable Energy, where he oversees the U.S. Department of Energy's sustainable transportation programs. And prior to joining DOE, he was in the transportation sector and automotive industry for 25 years, specifically in the areas of environmental, energy, and safety policy. So Deputy Assistant Secretary, thank you so much for joining us today.
Thanks for having me, Alex. This is great. I loved that last panel.
Well, so, I want to start by asking you about the big news, right? Because last week, the Biden-Harris administration announces a national goal of having 50% of auto sales be electric vehicles by 2030. I think it's fair to say this is an ambitious goal, but as we've heard, this is one that a number of our automakers are committing to as well. I'm curious to get your perspective on, what are the things that need to happen, from an innovation standpoint or a policy standpoint, but what needs to happen to enable us to get to 50% EV sales by the end of this decade?
It is a truly historic announcement, I think, and part of what makes it really special for me, listening to that day, was how you had government and industry and labor all coming together and recognizing this is where we need to get to. It is ambitious, and we'll need to go beyond that as well. But if we can get to 50% by 2030, we can do more. So to answer your question of what needs to happen, I see three pretty clear things that are the big things, right? There's a lot of many small things under that. First is we need to continue driving battery costs down. We've had tremendous progress, but we need to continue that effort to drive it down. We at DOE will do a lot on the innovation side to try to help make that happen. Of course, we need to do it very cooperatively with industry overall. And that's a combination of new technologies, new chemistries, new manufacturing approaches, as well as volume and scale. So, I am bullish that will happen, but getting to a number that's much closer to $60 a kilowatt hour in 2030 is what we need to have cost parity between a typical internal combustion engine and an EV. And when you do that, then we can have this big pull, right? Because without that, you can't mandate it just purely on a mandate level if the economics aren't there for people. So we'll get there, I think. Second thing that has to happen is we've got to build out the charging. I heard that from a number of people in the last panel. We need to now really continue to build that infrastructure out there. It is in the realm. It is something that is achievable. We can get there, but it's going to take a cooperation effort across utilities, state and local community levels, automakers all working together. And of course, we at DOE will play a significant role in trying to help bring people together, help make those things happen. Things like smart charge management to be a reality. And of course, in the bipartisan infrastructure deal, there's significant funds to help achieve the president's goal of 500,000 chargers and really providing a network, coast-to-coast network. The last thing that needs to happen is we do need to develop the domestic supply chain for batteries. And it goes a little hand in hand with the technology piece up front, but if we don't have the domestic supply chain, we won't get to the cost levels we need. Part of a domestic supply chain is battery recycling. 30 to 40% of the raw materials for future batteries, the critical minerals, we think can come from recycled batteries. But also developing the supply chain for all the individual components and the processing to help us make sure that we have a resilient supply chain. We obviously did a lot of work over the last 40, 50 years when we were in a petroleum-based industry to make sure we had domestic supply, and that was important. That will be as important when we talk about an electrified, low greenhouse gas future as well.
So it sounds like it really keeps coming back to the EV batteries and making sure that we're always improving their performance and developing those new chemistries and increasing their range and bringing down costs, like you said. All of that takes innovation, and I'm curious, what do you see as the federal government's role in helping to drive that innovation? What role does the federal government play in that?
I think the federal government can maybe play two roles here, if I think of it divided. One is we can help de-risk technologies. And, I think when a lot of people talked about significant amount of funds that are in the bipartisan infrastructure framework, part of that is significant funds for battery cells and battery supply chain. And we've shown a successful history over the last 10, 15 years of investing in de-risking technologies that are promising, but they're not quite there. They'll either take a long time for private sector alone to do, or there just won't be the capital to do that. So by us looking, making the smart investments on those earlier stage technologies, as well as getting to mid or later stage close to manufacturing, working very closely with industry, however, to make sure that we're not replacing what private industry can do. Because at the end of the day, the amount of money that private sector will put into whether it's charging or batteries will be well larger than the public sector can. But we can get that early stage piece going. So I think that's one. The other role we can play is helping to bring industry together and helping to be, if you will, the convening power, literally and figuratively sometimes, where just helping industry, if you will, organize standards. I mentioned smart charge management earlier, helping to provide a really clear path for when everyone says, we all know we got to get this done, but there's no one actor to help make some of that happen. Federal government can sometimes step in to help bring people together and provide that kind of standardization or convening power to help industry be able to convene around a common set of goals.
Absolutely. So, we started our conversation talking about cars, but, if we're going to decarbonize the transportation sector, of course, we need to focus on every mode. Now, we heard during our panel discussion about, new locomotive technologies and hydrogen-powered trucks and sustainable aviation fuels. In your view, what are some of the exciting things that are happening in the heavy-duty space? And on the other hand, where do we need to maybe pay more attention so we can make sure we don't fall behind on our way to net zero emissions?
I think right up front, one of the key things we have to do, and I have been preaching this for a while, so it's great here, is we have to think about the overall goal is decarbonizing all of transportation. To achieve a 100% net economy, net zero greenhouse gas by 2050, transportation has to be like front and center. It is the largest sector overall, and to do that, we have to think about all of transportation. So I think it's great the conversation you had. So when we look at that, certainly we can talk a lot about light duty, heavy duty, but also off-road has to be part of that, rail and maritime and aviation. So the strategy that we see is we've been doing a lot of looking at what are the right technologies in the right place. We have to have a sense of urgency, as I forgot who it was in the previous discussion brought that up, maybe our Carly. And in having that sense of urgency, we have to think about, we can't necessarily work on everything, but we also can't assume that one technology like battery electrics will be the solution for everything. So we do see a significant role for hydrogen, especially for those heavy duty trucks and for the long haul vehicles, also potentially in the rail space and the maritime space as well. We also see a significant role for biofuels because, as you mentioned, aviation, for sustainable aviation fuels, it is really the only path we see, especially for long haul flights. Now, shorter haul flights and some private commercial flights, maybe there'll be other technologies as well that can be there. In the case of heavy duty specifically, to your question, Alex, I think that the work we've been doing with the heavy duty truck makers show that in the next 5 years, we're going to be at a point where for shorter haul class 7, 8 trucks, battery electric will start making sense, initially for 100-mile, maybe a little bit longer. But so we keep developing the vehicles, absolutely, but we need to start focusing on how do we think about these corridors from a port, water port, if you will, whether it's inland or coastal, to these inland depots. I think every time I fly, and I'm trying to do it just a little more, you fly into a city, I swear, like the first time I flew after COVID, there were like 20 more of these large depots over any city I flew into with hundreds of trucks ringing around it. We need to be able to show that we can electrify, whether that's battery electric or hydrogen, maybe locally produced with local solar and local energy storage, bringing that together to make hydrogen locally, so you have to ship it. Electrify those depots, have 2 or 3 good heavy duty fueling stations with hydrogen electric along a route. If we could demonstrate that around a few hundred miles from a port, doing all the things around drayage trucks at the ports and the other equipment there, all the way inland, thinking to our rail side about the rail thing. Sometimes these trucks are now going to a rail yard for the intermodal connections. Demonstrating 3 or 4 of those corridors to solve the question of the recharging, refueling time, the dwell time. How do you make it all work? If we can work on that collectively over the next 2 or 3 years, demonstrate that, then we'll be in a position in 2025 to start really expanding. And we talked about a 50% goal for light duty vehicles in 2030. We got to be thinking about what that right number is going to be for medium and heavy duty as well.
Absolutely. This is so interesting because it occurs to me that, whether we're talking about cars or delivery vans or trucks, locomotives, dare I say, short haul flights in the future, electrification comes up, batteries come up. So this is a really, really important technology. I know last year, the Department of Energy launched the Energy Storage Grand Challenge to help accelerate the development and deployment of what I guess we call the next generation energy storage technologies. Can you tell us more about that, in terms of how it's going, that challenge, but also, is this a good example of how government and industry can work together to unlock the technologies we need to get transportation on a path to net zero emissions?
The Energy Storage Grand Challenge, it was a great initiative, is a great initiative. And it gets to one of these key points. We're talking about transportation, but we can't decarbonize transportation if we don't also first achieve our goal of 100% clean grid. And whether you're talking about hydrogen coming originally from electricity or battery electric directly, we need to have that green electricity. So The Energy Storage Grand Challenge was a recognition that to make that 100% clean grid a reality, we're going to need to have a increased level of storage. And that's not just battery storage, right? That includes a range of other storage. Today, pumped hydro is actually our largest source of storage on the grid. In the future, we think hydrogen will be a form of that storage as well, where you can be making the hydrogen and using it directly to avoid curtailing electricity. So the Energy Storage Grand Challenge also includes work on the vehicle side as well, because the lithium-ion battery technology we're developing for vehicles is currently, the battery technology that's being used for the grid as well. Now that may change over time. We'll see. So the effort is going very well from our perspective as a way to recognize how do we bring the different parts of the Department of Energy together first, and then how do we work with industry collectively so we're not working in silos but working across industry sectors. To your question specifically about public-private partnership, we see that there is going to be an increasing need as we're taking these technologies and moving them from lab into the reality. We have to have an increased number of these public-private partnerships. We announced I will point out that we announced a significant effort with the Federal Consortium of Advanced Batteries for a new overall lithium-ion battery blueprint, the first national strategy on batteries that's been done by the United States just a few months ago. And as part of laying out that strategy for batteries overall, one of the things we articulated is that we will be developing a new public-private partnership around batteries in anticipation of the significant amount of dollars that both the federal government will be spending, but also that the private sector needs to be spending, and the fact that we need to link the processing side up front with the supply chain, with the cell manufacturing, bring all these pieces together. We'd like to bring together that overall public-private partnership so that, again, industry can help themselves get organized, provide a forum for that. We as government can think about how do we most effectively work with industry. And a key part of all of this is the domestic job side. When we look at moving to electrification, a key part of that is how to grow the jobs front by the cell manufacturing, the battery supply chain, the processing, all of those components. We want to make sure that that is going to be done domestically to provide those new jobs there, so that we want to have overall a growing automotive sector from the employment side, not a shrinking one by power.
Absolutely. Well, Deputy Assistant Secretary, thank you so much for joining us today. We really appreciate your time and your expertise, and good luck with everything. There's a lot going on at DOE and across the administration on decarbonization, and this is all really important, so best of luck.
Thank you very much. Be glad to come back anytime.
Great. And thanks again to all of our previous panelists and to everyone for tuning in. If you missed any part of this event or want to rewatch it, you can visit Third Way's YouTube page, which is youtube.com/thirdwayvideo, or you can find a recording of this event on our website, thirdway.org. Don't forget to give us a follow on Twitter. If you'd like to keep up with our work on clean transportation and other climate issues, you can find us on Twitter at Third Way Energy. Thanks again for joining us today, and take care.